Welcome to EDU World Space.
We're told that a variable resistor, R, which varies between 0 and infinity, is hooked up to an EMF source of 15 volts, and the EMF has the battery has an internal resistance of 4 ohms. And also connected to the circuit are an ideal ammeter and an ideal voltmeter. And we have a circuit diagram, or a diagram given on the lower left side. And we're asked to find in parts A and B the the largest and the smallest readings of the voltmeter and the ammeter. So I'll do A and B together. So let's look at the limit when R goes to infinity. So what happens to the current and the terminal voltage in this case? So when the resistance is infinite, then no current is flowing in this segment of the circuit. And if no current is flowing, then the internal resistor also sees no current. So then we have that the terminal voltage is just that of the EMF, which is 15 volts. And the current is 0. And now we'll look at the opposite case when the resistance goes to 0. So when the resistance goes to 0, now we've created a short circuit here. And then in this particular case, we'll have the maximum current flowing through the circuit. And we can find the current by using EMF is equal to the current times the internal resistance, which tells us that I is equal to E over R, which is 15 volts over 4 ohms, and that is equal to 3.75 amperes. So that is the maximum current, and we would like to know what the terminal voltage is. So we can use VAV is equal to E minus IR, and that is equal to 15 volts minus 3.75 amperes times 4 ohms, and that is 0. So when R is 0, we have maximum current and 0 terminal voltage. And so we have now answered parts A and B, and let's move on to part C, where we're asked to sketch. We have a sketch of the readings of the ammeter and the voltmeter as functions of the variable resistor R. So let's do the the terminal voltage is a function of the resistor. So we found that when the resistance goes to infinity, we have sort of an asymptotic approach here of 15 volts. And then when the resistance is 0, we have 0. So when the resistance is 0, we have 0, and we increase asymptotically to 15 volts as R goes to infinity. Whereas for the current, we have kind of the opposite thing going. So when R is 0, we get our maximum current of 3.75 amperes. And then when R is infinity, the current basically goes to 0. So it approaches 0 asymptotically. So we have kind of like the opposite plot.